So in this, I'm going to be talking about reference angles. A reference angle is always a positive angle between the terminal side of the angle and the x-axis. So I'll let you write that down, and then we'll look at examples and illustrate what that means. It's always a positive angle, and it's measuring the distance to the x-axis. So, for instance, if I said 30 degrees, okay, we're talking about angles in standard position, and we know that means the vertex is at 0, 0, the initial side is positive x-axis. If I say 30 degrees, that is just your distance to the x-axis, so that is the same. If it's already between 0 and 90, your reference angle is your angle. That's how far it is to the x-axis. But if I say 135 degrees, that means the distance from here to my terminal side is 135. So we know this is 90, so 135 would be a little bit past that. The reference angle is the distance to the x-axis. So it's this angle over here. We call the reference angle a lot of times theta prime. So tick mark means reference angle. How would I find the distance to the x-axis? We get 45 degrees. So this one has a reference angle of 45 degrees. I said 240 degrees. So it starts here, 90, 180, this would be 270, so it would end somewhere in here. So this distance is 240 degrees. Reference angle is how far it is to the x-axis. So that's going to be this angle right here. How would I get that? That would give us this part here, but you're not far from it. We want the distance just to the x right here. This is 180, and this is 240. So and we get 60 degrees. I said 330. It's 90, 180, 270, 330. So it's taking me all the way over here. So in this one, the distance to the x-axis is this final angle here. So this time, what are we going to do? I get 30 degrees. Okay, you guys try E and F. See if you can figure out what those reference angles would be. So 210 ends up in which quadrant? 3. If that's 210, how did you find the distance to the x-axis? We get 30. And 140, what quadrant is that in? This is 140. Distance to the x-axis. We just do 180 minus 140. And we get 40. So it's just a matter of subtracting, involving 180s or 360s. because you're measuring distance to the x-axis. And in fact, the rule depends on your quadrant. So in each quadrant, in quadrant 1, your reference angle is your angle. You don't have to do anything. So if your number is already between 0 and 90, it doesn't change. In quadrant 2, so if we look back at our problems, to find the reference angle in quadrant 2, that's when we did 180 minus our angle. So quadrant 2 is 180 minus your angle. When we had an angle in quadrant 3, so if we look back, that was the 240 or the 210. We did our angle minus 180. And in quadrant 4, we subtracted from 360. So we have to get a positive angle. If you do the wrong way, if you do 180 minus theta instead of theta minus 180, you'll get a negative. So you'll know. When you find this, you should get a positive number between 0 and 90. That is a reference angle. And reference angle is always distance to the x-axis. So we're using 180 and 360. You will never, ever, ever subtract 90 or 270 because that will give you how far you are to the y-axis. So for non-acute angles, if I want to evaluate my trig functions, we will use the reference angles. If I were to set up a triangle here, it's the same as a triangle in the first quadrant, except here x and y are negative. So we'll look at the quadrant to decide if it's positive or negative, and then we'll evaluate everything based off the reference angle. So let's do some problems now. If I ask for the exact value involves radicals, so it is not on a calculator. From now on, any of these problems, I'm going to ask you for 2 pieces of information. I want you to write down your quadrant and your reference angle. So from here until you take the final, when I give you a question, if it's not just between 0 and 90, I'm going to say, okay, what quadrant is it? What's our reference angle? So 240 degrees is in what quadrant? Okay, to find our reference angle in quadrant 3, what would we do? We get 60. So now to evaluate it. Remember, all students take calculus. This tells us when things are positive. In quadrant 1, they're all positive. In quadrant 2, sine and its reciprocal cosecant are positive. Quadrant 3, tangent and its reciprocal cotangent are positive. Quadrant 4 is cosine and its reciprocal secant. In quadrant 3, is sine going to be a positive or a negative value? Negative. All right, now we're looking at 60 degrees, the sine of 60 degrees. So I use my hand trick, fold in my 60, sine is the square root of the top over 2. So it's negative radical 3 over 2. So the quadrant is how I decide if it's positive or negative. The reference angle is how I know which finger I'm using on my hand trick to evaluate it. So if I ask for the tangent of 315 degrees, what quadrant is 315 in? 4. Reference angle in quadrant 4, we do 360 minus 315. And if you ever get confused on that, draw yourself a picture, just like we figured them out before we wrote the rules, and get 45. Okay, all students take calculus. In quadrant 4, cosine is positive, so that means tangent would be negative. And then I have the tangent of 45 degrees. So I did my hand trick. Tangent, square root of the top over square root of the bottom. So radical 2 over radical 2 is, so tangent of 315 is negative 1. Cosecant of 300. What quadrant is 300 in? Quadrant 4 again, so reference angle 360 minus 300, 60. In quadrant 4, cosecant is the reciprocal of what? Sine. So let's think about sine for a minute. In quadrant 4, is sine positive or negative? Negative. And then I'm thinking about the sine of 60. So the sine of 60, square root of the top over 2. So to get cosecant, what do we do to that? Flip it. So 2 over radical 3, so we get negative 2 radical 3 over 3. What questions do you guys have for me so far? Okay. First one, keep practicing this. So if I ask for the 6 trig functions for 585 degrees, right. What would I need to do to this? I can't even just tell where that is. What would you do first? So we find that coterminal angle, so that's 225. What quadrant is 225 in? 3, because it's between 180 and 270. So reference angle in quadrant 3 is your angle minus 180, negative 45 degrees. Okay, I asked for all 6 trig functions this time. So you could write, sine of 585 degrees. I'm just being lazy and I'm just putting theta instead. In quadrant 3, all students take calculus. Which ones are positive? Tangent and cotangent. So the other 4 will get a negative. All right, then I go to my hand trick. So 45 degrees. Sine is the square root of the top over 2. Cosine is the square root of the bottom over 2. Tangent, square root of the top over square root of the bottom. Radical 2 over radical 2 is 1. For the others, we do reciprocals. So if I flip this, 2 over the square root of 2. That's negative 2 radical 2 over 2, or just negative square root of 2. Secant will give us the same thing, negative square root of 2. Cotangent reciprocal of 1 is 1. Let's look at this one. So we have to evaluate all of these functions. When we see sine squared of 45, that means I'm taking the sine of 45 degrees and squaring it. 3 cosine squared of 135 means I have to take cosine 135 squared and then multiply by 3. So we have to evaluate each of these things. degrees is in quadrant 1, so we don't have to worry about quadrant and reference angle. What is the sine of 45 degrees? Cosine of 135. That one I have to work out. 135 is in which quadrant? Reference angle, 180 minus 135 is 45 degrees. All students take calculus in quadrant 2. Sine is positive, so cosine would be negative. Cosine of 45, so the square root of the bottom over 2, so radical 2 over 2. Right. Minus 2 times tangent of 225. What quadrant is 225 in? Reference angle. 225 minus 180 is 45. In quadrant 3, tangent is positive. Tangent of 45, square root of the top over square root of the bottom is 1. So if we work this out, radical 2 over 2 squared, 2 fourths or 1/2. 3 times 2 over 4, 6. 3 times 1/2. And it is here. So on a problem like that, you have to evaluate each piece. I think I'm going to stop here because I want you guys to work on problems in practice. There's actually only one example left, but it's kind of changing gears, so I don't want to do that yet. I want to make sure you guys understand this before I put anything new on there. So the assignment, technically you could do everything except the last 2 problems at this point, and you do have quite a bit of